Hello, so in this video series we are going to build a stopwatch app. The app should look something like this, where we have a stop, a start button, and the reset button. So the button here can be start if the timer is stopped, and then stop if the timer is started. And we have a timer here, and then we can stop the timer, and we can also reset it. And so this is what we are trying to build, so let's get started. So the first step here is to start a new project in Android Studio, and so let's pick just an empty activity. Let's call it Stopwatch demo maybe, and that should be good enough. We want colon, and here is the app. Okay, so the first thing we want to do here is build our layout. So let's go to the layout here. I usually prefer to just do the code one. Let's do split so that we can see what we are doing here. And let's make this a little bit bigger. Cool. Now, we don't want a text view here. What we wanted is something like this, where we have this view here, then two buttons, stop and reset. For now, let's just do this button and leave reset for later. So we need this here. We can use a text view, or we can use chronometer, which will allow us to have the timer automatically handled, right? So here, what we need is a chronometer instead. So let's replace that. And that, you can see here, gives us the format of a timer here. So let's give it an ID. And the ID, let's call it timer. Let's leave this as wrap content. Let's remove the text. And we want it centered, so this is good. And then we want the button here for the start button. And so let's give it wrap content, and then let's give the button a text. So the text would be start, right? So we can extract this into a string. The name is start, and we want an ID here. And let's call the ID toggle timer, because it will be named start if the timer is not started, and then stop if the timer is started. We will need to give it constraint. So here we can see Android Studio is complaining that it's not constrained and it's inside a constraint layout. So we'll need to constrain it. So first we want it centered, but we want it below the chronometer, right? So let's just set it up here. What we need is, in order to have it centered, we need to set the constraint on the left. So app constraint left. Actually, that's not what we want. We want app, we want layout constraint, and then we want left and to left of. And we want it to be left off the parent, right? Basically, what we want is the same as here. This is what makes the timer centered horizontally, right? So we want the same thing. So let's just copy and paste it. And then we want it to be below the chronometer, below the timer here. And so to do that, we can just use constraint layout and make it below timer. And so to do that, we need, app, and then we need constraint, and we need to say the top is to the bottom of timer. The top of toggle timer button is to the bottom of the timer button. And so to do that, we just do add ID timer, right? And this, you can see, just made it immediately below the chronometer here, below the timer. Now what we want to give some spacing between the two views. So let's just give it some margin top. Layout margin top of 10 dp, and that should give some space between them. Okay, so let's just see what this looks like. So it looks like this. We have a timer, and then we have this start button. It doesn't do anything yet, so let's wire it up. So the first thing we want to do here is set the click listener so that when the button is clicked, we can start the timer, right? So our button here our button ID is toggle timer, so let's just use that, and we want to set so let's just import it using Kotlin synthetics here. So you can see now the view using the view ID it was imported. All basically view IDs are imported using this, right? And so now we can set a ClickListener, and we can start our timer for now, right? So we can just start our timer. So this is a method. So timer is a class chronometer that Android provides. It just extends the text view but has some additional methods that can help us, like have a format, set a timer that counts either up or down, and we can set a listener to get called every time a tick happens, like 1 second, 2 seconds, 3 seconds. And now we start the timer. Then we want to set once it's started, we want to set the text to stop, because then the button, when it's clicked again, it stops the timer. So we could just take the button here and set the text to be get string, dot string, start. Let's just move this. Okay, so now we want stop actually. So let's create this string, stop string. So that will be the source value is just stop. And one other thing we want is, once we set it to stop here, let's just first make sure this works, and then we could, so basically the next time we click, we want it to, so basically here we start the timer, right? And then it's stopped now, but when I click stop, nothing happens. So right now what we want is, when it's stopped, we want to stop the timer and then change the text back to start, right? So to do that, we need to keep track of whether the timer is started or not, so that we can know when to start it and when to stop it. So for now, we can just use a simple Boolean flag here. So let's just have a value here that says if the timer is running or not, start as false. And then here, when we start the timer, now the timer is running, so we set it to true. And now when you click on this toggle button, we can check if the timer is running. Then we want to stop timer, right? But if it's running, if it's not running, then it's this case, we want to start it. So it's this case that we already implemented. So now if it's running and the button is clicked, which means it was, the text was stop, then we want to stop the timer. And we want to set the text back to start, right? And then we want to set the flag back to be now running, right? Okay, so now let's test this out. So if we start here, we can see the timer starts running. Then we stop, we get back start, the timer is stopped, we start again, continues, and then we stop, timer has stopped, we start again. Yeah, so now our timer looks good. But now if we have one small problem, which is, so if I start the timer here, and then I change the orientation, timer is back to 0. It doesn't continue, right? It should, when you change the orientation and the timer was already running, it should keep running, right? Here, if I start, it still picks up from where it's left off, but the timer was reset. If I change the orientation again, just wait for it to. Let's do this again. Okay, so you can see the timer has reset again. So if I do it again, one more time, it's 0. So let's fix it. So we have two ways of fixing this. One way is to use unsafe instance state and just put the value of the timer there, and then when we restart, the activity is back, we can put the values again. But the right way to do it right now is using a view model and keep all the UI data in the view model and have the activity observe some data in the view model, and when the data changes, the activity updates. But all the data should be in the view model, and all interactions with the data should be in the view model. This will have the additional benefit of allowing us to test the behavior in the view model. So let's create a view model here. So let's just go here and create a view model. Let's call it main view model. Let's choose a class, and view model here, we can make it extend this Android class, the view model, that the framework provides, that we can use for an activity or a fragment. And so here what we need is the variable that we used here in the main activity for the timer, which is a data that the UI uses, should be in the view model instead. So what this would mean is we will need to define it here in the view model, and let's have a mutable live data, and this is just where we could choose the type of the value. Here it would be Boolean, whether it's running or not, and live data is just so that the activity can observe when the value will change. Here you can use ArcGIS for this, or coroutines, but we are just going to go with live data. And here the type is Boolean, right? And we want to initialize it to false, right? Because at the start of the activity, we want the timer to be stopped and to be at 0. And then when you click start, then we want the timer to start. And so we set this to false. And now we want to switch the content here, the logic for if the timer is running stop, and when the timer is not running start, we want to switch that to be in the view model. And so what we need here is a function that we can call toggle timer, right? And this function here would check the value in is timer running, right? So we can just check the value, that value. Let's just say if this is equal to true. So why do I have to do equal here? Because the value here is nullable, right? And so we want to make sure it's not null. And so here we want to stop the timer if the timer was running, and if the timer was not running, then we want to stop the timer. And this is the same as what the logic we did here in the main activity. So if the timer was running, we stopped it, and the timer was not running, we started it. So let's define these two functions here. So the first one is start timer. So let's first define the stop timer one. So that one, we want first to change the value to be that the timer is no longer running. So the same thing we did here for the activity, false. And then for start timer, we want to do that. We want to say that the value here is equal to true. The timer is running, right? Now, one more thing here is that we want the activity to text here, activity to change the text, and this is a UI behavior, and so we want to do it in the activity still. But when you click listener here, we no longer want to call the view model, and so first we need to get a hold of an instance of the view model in the activity, and to do that we can use view model provider that Android provides here. So view model provider, which is just a store of view models for the activity that we are in here. And so we passed with the lifecycle, the view model store here, which is the activity, and then we want to get the view model, and this is just, there is a get function here on this view model provider. So first, let's just say this is a view model, and we want to get the main ViewModel class. So one thing we want to do here is get the Android Lifecycle library here, ViewModel Lifecycle Library, which is this one. You can just pick up the name here from the Android documentation, and then once we do that, if we go back to the main activity, now we have our ViewModel provider working correctly, and this is equivalent to get. In Kotlin, you could replace the get with just sort of a map like usage, but you could also use get here. Now, once we have the ViewModel, we want to call the ViewModel to toggle to call the toggle logic. So we want to toggle the timer here, and we no longer need to do this in the activity. We just need to do the part where we change the text. And to do that, we want to watch the state of the timer, whether it's running or not, and just observe it and handle that. And so to be able to get the state of the timer, we may need to expose it to the activity. And so I'll just create a function here that, let's call it timer state, that returns a live data, a non-mutable one. We don't want the activity to be able to change this one. And we want to make this just the state of the timer. And so in the activity now, we could take the ViewModel, get the timer state, and observe that one. So when it changes automatically, this will be called to change the view text. So we could observe and pass the activity, which is the lifecycle owner of the ViewModel here. And then we could pass a callback here that gets called when the state timer changes from running to not running or the other way back. And now we get, let's just call this is running. And now we could use this variable here to check. So it is running. So if it's running, we want to change the text. Else, we want to. So maybe we could even do something like this, and then just use is running here. Otherwise, we want to get stop. And this, the problem here is the timer state here exposes live data of Boolean, which can be nullable again. So let's fix that. Okay, let's first just do it with if here. If it's running, let's do it like this, just so that it's more clear. Otherwise, we wanna change this to stop actually here. Otherwise, we want to start here, right? Okay, cool. So now we can get rid of this. We will need to still stop the timer because the timer is a UI view. It's a chronometer class that we have defined here, and so we want to call start and stop on it. And so to do that, we will need here, if the timer is running, we want to stop the timer. Otherwise, we want to stop the timer. And that's pretty much it. We can now get rid of this and leave just the call to the ViewModel. And now we can remove this variable also. The variable is now in the ViewModel. And now if we run this again, let's go back. Cool. So now if we start the timer, okay, so now one more thing we want to include is the ViewModel saved state library for saving the state. So let's sync here. And then now in the main in the ViewModel, sorry, we want to have a start value here, right? And we want the timer to be initially not running. So we say false, so that initially we want the timer to be considered not running, and in the activity it's initialized to start, which means it's not running. And so that's what we want, right? So now once I run the app, I have the timer running. If I change the orientation, the timer is still on the running state, right? So if I change the orientation again, change it back again, it's still running, but the problem here is that we restart the timer. So here at 5, and then it starts at 0 again. So what we want is to keep track also of the time we, so for example here when it's 9 or 10, when we switch back to the other mode, we want to pick up, when we change the orientation here from at 18, we want to pick up 19, 20, and not go back to 0. So that means we want to save the timer, like how many seconds or minutes elapsed. We want to save that in the view model and put it in the UI once we change the orientation, right? And so this we will do this in the next video or in the next episode.